because it's just not a feeling.
That's useless.
On top, please write the word transformation. And ladies and gentlemen, that is simply answering the question how a shape moves from one place to another. And with transformations, really, you just need to know the three different ones. Okay? The three different ones, and they are these. You have one which is a translation. Translation. You have something we call a I don't want to give the whatever. The reflection. And we have the third one, which is a rotation. And these are the mathematical names. We can put some generic names in there to help us. The word translation, really, I mean, it is just basically when you slide a shape. And I'm going to grab a shape up here. Let's use a right triangle just because. Oh, wait, maybe can I clone this? Let's clone this bad boy. What means this? If, wait, let me put this up here so it doesn't get in the way. A translation means nothing more than this. When something is translated, it is simply slid to a new position. It does not turn, it doesn't do anything, it just moves from one place to another. Okay? And you could, they might ask you, well, no, they won't ask you. So it's basically a slide. It does not, it stays pointed in the same direction. Same direction. Now, a reflection, on the other hand, children, let me put this on top of each other. A reflection is the same thing as pretty much a mirror image. Which, when you look in a mirror, what happens? It kind of gets put backwards. So a reflection of this means this. Let me see if I can get this to do this. Okay, it kind of, I mean, that's as best as we're going to get. And usually there is an axis of reflection that is kind of folded about. Is that better? Look at that. That turned out pretty good, didn't it? Yeah. Ain't too bad. Ain't too bad. And then the last but not least, we've done these before. A rotation is simply when you spin something. So if we've got our little triangle here, basically you would take that and usually, okay, they'll ask you, they'll spin it about a point, and right here would be the point that this is spun on, and it spins in this direction, which is a, how many degrees would that be? Turn. How many degrees would it turn? 90 degrees. Because all you have to do is think about what lines go with what lines. See how this line is the same as this line here. So that's formed a square angle. It just turned 90 degrees. If it was 180 degrees, that would end up looking like this. Again, line doesn't spin on that point. That would be 180 degrees. If it was 270 degrees, it would end up looking like close to this. And if it was 360 degrees, it would end up back to where it started. Well, let's just put a 90 degree on there, can we? Is that 90 degrees? Yeah. Now, you ask, what kind of things will they ask us?
What kind of things are they asking us?
I don't really know. I'm gonna look for reflecting. Let's just do one example of this. Well, no, let's not. Let me throw a couple more things in there. The other thing that comes up in transformation is something the book calls a dilation. You ever go to the eye doctor and they dilate your eyes?
Oh, yeah.
That just means that it gets bigger proportionally. Okay, so if you had, I guess I have the triangle already there. You know, if you have a triangle and it is dilated, that would mean we'd have to pull that all sides end up growing equal in proportion, which means if this side was 2 times this side would have to be 2 times that, and this side would be 2 times that. So that's just a dilation. I'm trying to figure out what they do actually. Right, look at page 174 in your books, would you please? At the very top of page 174, just so you know what they're talking about, it says rectangle PQRS is dilated with a scale factor of 3, forming P prime, Q prime, R prime, S prime. That's what that little apostrophe thing means there. All right, which means this, ladies and gentlemen. If this was a problem in my book, the first thing I would do is sketch Mr. Rectangle number 1, which is rectangle what? P, Q, R, and S. P, Q, R, and S. And I would label the sides accordingly, which is 6 centimeters by 4 centimeters. Now, what does it say happens to it? It is dilated by a scale factor of 3. And all that means is every dimension is just multiplied by 3. And that's what the new rectangle is. So instead of this being 6 centimeters, it is going to be 18 centimeters. Instead of this being 4 centimeters, it will be 12 centimeters. And this would still be 18 centimeters, and this would be 12 centimeters. And then, to show that this corresponds to point P but is not point P, that's why they put that little apostrophe there, and it's called P prime. This is called Q prime. This is called R prime, and this is S prime. Now, one of the things they try to show you with this is this. First of all, thinking about the perimeter. What's the perimeter of the small rectangle? What is 6 plus 4 plus 6 plus 4? Perimeter equals 20 centimeters. Well, guess what the perimeter of the big rectangle is? Let's actually do it. 18 plus 12 is 30. Plus another 18 and 12 is another 30, so it is. Now that's logical, is it not? Because our scale factor was times 3, and that is times 3. Here, however, boys and girls, this is what I need you to start thinking about. What always seems like common sense, Charles, is not always common sense. Because you would also think that the area, since it was 3 times bigger, would also be 3 times bigger. Well, let's look. The area of the small one is 6 times 4, 24 centimeters squared. But I will tell you that will not be the case. 3 times that is 72. Okay, the big one is actually 12 times 18, which is 36, and 18, which is 216 centimeters squared. How many times bigger is the new one than the old one? I won't ask you to figure that out, but it is actually 9 times bigger. And Danny's going to say, but how can that be? Well, here's the reason, children. When you did the scale factor, you didn't just multiply by 3 once, you multiplied by 3 twice. In other words, I multiplied this 4 by 3, and I multiplied this 6 by 3. That is 2 3's that I multiplied together, giving me a total multiplication of 9. Okay, I multiplied 2 dimensions by 3, which means I actually doubled 2 sides. And when you do area, it's 2 sides, not just 1. Perimeter doesn't matter because perimeter is just a length. But area, and by perimeter you don't multiply, you just add stuff together. But area, since you multiply 2 things together, I multiplied the length times the width, right, to get the area. But you have to remember, I multiplied, when I did my dilation, I multiplied the length by 3, and I multiplied the width by 3, both of them. And when you multiply 2 3's together, that gives you a grand total of 9 times bigger when you do the whole thing out. You won't get that, but I'm going to tell you that like 18,000 more times between now and when you finish with 8th grade, but it's just the start of that. It's a little like this, ladies and gentlemen. If you go and buy yourself a rectangular pizza, does anybody serve rectangular pizzas? You go, and this place sells a rectangular pizza that is 10 inches by 10 inches, and they sell that for $5. And then they say, we'll sell you one that's twice the size, which is 20 by 20 for $15. Which one is the better deal? This one. Why is that? Because there are actually 4 of these little pizzas in that big one. Because remember, this is a 10 by 10, so it's a 10 by 10. Here is one of these little pizzas. There's a second one. Here's a third one, and there's a fourth one. Again, because you doubled 2 dimensions, you're getting 4 times more when you do that. Just the way it goes. I can't stop it. I can't change it.